Hello, and welcome to another episode of Cooking with Unity. I'm your host, Max Moreau. With me is my co-host, Philip Wilson.
I am here.
You can see his shoulder.
You can.
It's crazy.
It's creepy.
Yes. So, anyway, we're going to be doing more Mario Galaxy stuff tonight. And I actually am going to apologize in advance because I'm pretty sure that we ran into some pretty difficult mathy issues last time that I said I was going to investigate, and I had no time to investigate any of them. So we're going to be fighting through this again. I've left it kind of open as to what we're doing, just in case we get stuck on one direction. We'll just find something else to implement and have some fun. We might add an enemy. We might add some particle effects. I don't know. We'll figure something out. So, do you have anything you want to add?
No.
Okay. That's boring.
I'm boring.
All right. So, back to the show at hand. So, in our last exciting episode, what did we have running on this thing? So, oh yeah, I forgot about the dude.
Oh,
Papadorian, man! That's awesome.
The best thing ever.
We arted last episode.
And we got Papadorian.
We arted hard, and we also broke our physics.
Yeah, we definitely broke it.
Oh wow, this is not so great.
No, but it has Papadorian.
It does have a Papadorian though, which is awesome.
I think it's funny that we call him Papadorian.
I do too. That was a great name for him, man. That was all you.
I think it's
Where's
funny.
the other planets? Are there other planets?
There are. I just don't think we can get to them.
I'm sure we can. There they are. I just couldn't see them. I'm going to try. Come on. Make it. Yeah, you made it. You're kind of like... You just don't orient properly at all, but that's okay.
Papadorian, we need to fix your orientation.
Yes, we do.
Papadorian.
All right, so what do we got going on here? So the camera AI actually is looking kind of cool now. It's a little bit disconnected, and it's a little bit disorienting right now just because the player's not actually in the proper orientation. But I think getting the player oriented right will actually fix this. I'm going to give a stab at it for the start of the show. And then if things go poorly or we don't find if we run out of options or ideas, we'll probably move to something else. But I'm gonna go ahead and see what we can do here. So the last time, what we had going on is we changed our code around so that it's no longer. First of all, we fixed it so that the player now uses a proper forward vector. So before we had kind of made his forward vector used for his facing to the planet, and now his forward vector is actually his forward. So his eyes, well, not his eyes, but his lips at least point in the forward direction. His eyes kind of point in whatever random direction they want to point.
He's derpy.
Yes. And so before if we clicked on this, it would show the blue arrow pointing. I forget if it was upward or downward, but it was one of those directions.
I could not remember.
So now we've got it more oriented the way that we want it. And the reason we did it the other way before is just so that we could use look at the gravity vector or the opposite of the gravity vector, and it would just put us in the right position. So we now need to figure out how to actually get that into our equation. So what happened is we now have... Yeah, there's lots of text. There's a lot of stuff in here. I'm going to go ahead and zoom in a little bit, just in case people are on slower connections and running the lower resolution stuff. So what we've got going on is we get the movement direction, which is just the input stuff, and we care about... so we rotate the player to face the movement direction, and we only do this if there is a movement direction to work with. And right now... Oh yeah, I remember what I needed to research on this that I didn't research. So right now we're rotating towards it. First of all, we're just giving the movement vector directly to the player, so that causes some of the skipping around that you may see. Like, we basically are telling him to go, if the camera's pointed forward, he just starts going forward, and you can see that he's trying to actually push through the planet right now. Like, we're actually giving it a little bit of force, but it doesn't really do much right now. And you can see that he angles kind of oddly when we press multiple buttons at the same time. And it's because we're using quaternion.look rotation in the movement direction. And we're using negative gravity vector as the vertical, but that basically is just to try and maintain that as a vertical. It doesn't mean that it will lock it as a vertical. And so what we need to do is we need to give him a movement direction that is based both on the camera facing and based on his normal against the planet. Like, he basically should be touching the planet with his feet and then looking as forward as possible towards whatever the camera is looking forwards at.
Yes.
And so what we probably need to do is vector math. And we're probably going to need to do some things that we haven't really done on the show before. Namely, we've done dot products before, and we're probably not going to need that. But we're probably going to need to do projections, and we're probably going to need to do cross products. And quite frankly, I didn't spend the time that I wanted to try and figure this out offline. So we're going to kind of toil through this.
Okay.
So what a cross product is, let's start with that. Cross products
Let's have some maths.
are super useful. And you'll understand why as soon as we let's do vector cross products. So what it does is if you have two random vectors, like two vectors in three space, right? The cross product of it, the most important feature, there's a few different features of this, but the most important one is that the cross product generates another vector. So you take a vector and you cross it with another vector and it generates a third vector. And that third vector is perpendicular to both of the first two vectors.
Yeah.
So you could have so what that means is if you have, say, a downward vector, which we do, we have the planetary gravity vector that we can work with, and then we had, say, a forward vector, we could get a right vector from that is perpendicular to both of these, and then we could use that on the ground vector again, potentially, to get a new forward vector that is now facing the direction that we want with that perpendicularity that we want.
Okay.
That
I think
really
I
need
understood
to,
what happened there.
I really need to actually get a diagram, although I'm not sure. Let's do it. Let's pixel major it. We'll do another one of my terrible diagrams. I am actually one of my many myriad projects right now is a Unity project that is for showing how to do vector stuff, and I just kind of want to make it so that I can do diagrams on the show that don't look terrible. But for right now, we're just going to do it the old 2D way,
the old-fashioned way.
So if you have I can't draw 3Ds at all. Let's do it in here. So we're going to use cylinders to represent this. And so you have a vector. I'm going to stretch this out a little bit. Just go like, wrong stretch. Y, is that it? Yeah, there we go. And then we'll duplicate that, and then we'll just rotate this one kind of in a random orientation. Rotate, we'll just do kind of like, whoops. I didn't evidently duplicate it, even though I thought I did. Command D, duplicate, that's under here, edit, duplicate, all right. So we have two vectors represented by these sticks, and I'm going to put them so that their bottoms touch. That sounded wrong, but basically, vectors don't have actual position in space. They are just direction and magnitude, so you can replace them anywhere when you're doing math on vectors. And so typically you put them in positions that actually make the most geometric sense. And so in this case, what we're doing here is we're showing, you got to pretend that these are the tips. Where the green arrow comes out is the tip. I didn't render out a tip or anything. Yeah. So the cross product between these two will result, and I'm not going to have the scaling exactly right on here because there actually is significance to the scale, but it will result in a vector that looks like, I'm going to ballpark this. This. So you see how that's perpendicular kind of sort of to the other two. Pretend that it actually is perpendicular. My models may not be exact here. So that's one of the vectors. It also could have been pointed the other direction. The relationship, the direction it points depends on which one you cross first, and the length of it has to do with the angle between the two, I think, or it might have to do with the magnitude and the angle. I'm not going to go into that geometric property on this show because what we care about on this one is just the perpendicularity. And so the theory I'm going to have here, let's actually try and make this into a real-world example. So when we have the player, let's say the player is down here.
Yeah, that makes sense.
And so let's say the camera was initially facing the same way that the player is. So we've got a forward vector from the camera when we press forward that goes, let's do another, capsule will be fine. Capsules now. Oops. Rotate. So the camera has this forward vector that goes out like that. Okay, hold on. We'll fix that. Hold on. There, it's coming out of his head now. Now you don't have to think about it. Remember, it's coming out of the camera. Don't even think of it on the character. It's on the camera. All right.
Oh, good thing I'm an adult.
Yeah. We are both definitely adults and not into juvenile humor at all. And our favorite album is not Starbomb by Ego Raptor, which is the least juvenile of all albums.
Yeah.
Wait, okay.
Yeah.
So we have this vector, and we want him to be facing a different vector, though. So we've got another vector here that we're going to be using, which is I'm going to represent by another capsule. Math is fun. And this vector is going to represent our little gravity vector. And I'm going to point it away from the planet, though you can just fix that with a negative, so it doesn't necessarily have to be pointing away from the planet. Our gravity vector is actually pointing towards the planet, but so we've got that vector. And so what we want is ultimately to have the vector that is the... I'm going to duplicate this one and move it over a little bit. What we want is the forward vector for the player. And the forward vector for the player should be, if he was on this part of the sphere, it should be something along the lines of this.
Right there.
Yeah, that right there. And so let me move that into position to show kind of where that's coming from. So if he's sitting on the planet there, he should be facing forward here.
So
we don't know this vector. We got this vector by visual geometric deductive reasoning.
But that's what
here.
we need.
But we need this mathematically. We need to figure out a way to do this in script.
With maths.
With maths. So what I was going to propose to do, and I'm not sure if this is the most efficient way to do this, mind you, but what my proposal is we can take the cross product of these two, so I'm going to duplicate that, and this will end up with a vector that looks something along these lines. So now we have a rightward facing vector, right? Okay, so let me actually clean that up just a little bit on the rotation there. Let's not use local, let's use global. I don't know. It's close enough. So we got this rightward facing vector, which isn't what we want. But from here, we can then cross this with this, and we should end up with this vector right there. See? Mm-hmm. And so that's what I'm going to propose for our math here.
Absolutely.
Yeah. So this is the reason that that cross product is powerful, is because you can do these relationships. I had to do a lot of cross product work actually when I was playing around with the source engine, because there were things I wanted to do that required certain information, and they didn't store a whole lot of information for the character. It wasn't like the transform system on Unity where there's a lot of magic functions you can use. It was more like we have the ground vector and we have the direction you're facing, but if you want anything else, you're going to have to play with things to get it. So anyway, this is... and that may have changed by now, and I may have also been using the engine wrong because I wasn't a developer on the project. I just was making mods for it. So so this should be what we want to do. So what we're going to actually do now... That was much better than drawing. I'm glad
I think that actually was very good.
All right. So what we're going to do is... So we have our movement direction, and that's not actually what we want to be the movement direction. So this is going to be the camera movement direction. And then, so, because we don't even want to make the character's position move based on this, we want to actually get what his input would be on this.
Yeah.
So, we ultimately want to have the player forward direction. I'm going to call it a vector 3.
Because that's what it will be.
And so
Sorry for the squeaky chair.
We're going to do, so we have camera movement direction. Do we already have the gravity vector yet? Okay, no, we don't have the gravity vector, so let's do that over here. So we're going to need that, and we're going to need... Alright, I'm going to have to reorganize this a little bit. So let's do this calculation earlier, at least the gravity vector calculation.
Okay.
So we have our gravity vector, we have our camera movement direction. So again, camera movement direction here, gravity vector here.
That's the gravity vector?
Sorry, no, gravity vector here.
That's the gravity vector.
Then we're going to do this in between one, which I'm just going to call the rightward vector right now. It may be pointed to the left. We don't even care. We just want this thing for another cross product later. This is a building block. So I'm just going to call it rightward vector 3 rightward vector equals, and we're going to do vector 3 dot cross the camera movement direction, and the gravity vector. And then finally, the player forward direction should be what happens when we cross the...
That's the rightward vector with the...
So this would be crossing the gravity vector.
With the rightward vector, right?
Yep. Vector 3 dot cross gravity vector rightward vector.
So now if we didn't screw something up completely.
So we have this one, we cross it, we have this one and this one, we cross it to make this one, and then we take this one and cross it to make this one.
Can we do a debug log just to see if we're on the right page?
Yeah,
with all this?
Yeah, let's see what we can do that would be useful. A debug log is probably not going to be the most useful thing, but we could do a debug draw of some kind.
Oh, that sounds like a good plan.
So let's do that.
An on-draw gizmos?
Yeah. Yeah, as opposed to... Yeah, let's do that. So,
so we can see kind of what it should be where the player is and get a good visualization.
So in order to do that, considering it's going to be in a separate call, I'm going to have to make these into kind of... I'm going to, at the very least, have to make the player forward direction something that we can look at. Actually, you know what I'm just going to do? I'm going to make it simpler. We're not going to do the debug stuff on this. I'm just going to look at what the character's facing as if we do a set to this direction. So what we're going to do is, instead of doing quaternion look rotation movement direction, we're going to do it in the player forward direction.
Okay.
And we're still going to use negative gravity vector there. And so let's see what happens if we hit play. Oh, we already have a problem. Movement vector does not exist in the current movement direction. Oh yeah, because we changed it from camera movement direction. So let's not worry about his position just yet.
Okay.
And let's just see what happens.
That sounds like a good plan. I like seeing what happens. Yet again, movement direction.
So this one we'll just do one of these. Oh, wait, we do want to have the magnitude. So let's use the camera movement direction. That'll be fine for this. Save.
No more errors?
And no more errors. So now I'm going to...
Maybe... Are we going
to keep those? I'm just going to disable the renderers on them for right now, just in case. Just in case we want them for reference again later. And these ones I'll actually delete because this was my just hackney example. So I'm going to move him out so he doesn't fall through the planet.
Which he would do.
Which he might, yeah. So I'm going to go ahead and play here. And if we go back to the scene here, it didn't look like it did much right at all.
Well, we should at least put a print call or something like that.
Yeah.
I mean, there's got to be something.
Oh, wait, he didn't do anything because we have no camera movement direction. So if I hit forward right now... So I'm going to have to bring the game up menu so I can do this. If I hit forward, he should snap to either... I'm going to guess that he's going to either be exactly right, going forward this way, or he'll be 180 degrees rotated.
Okay.
So I'm going to hit forward now.
He's
Exactly right.
Cool.
High five.
Yeah.
Math for the win.
That's awesome.
All right, now you guys know what a cross product is, maybe, and how one of the ways it can be used. Now, as I said, there are other properties of cross products. I'm sure that James could come and be here and be like, "Oh, there's all this cool stuff you can do with a cross product. Look at all this stuff that you can do with a cross product." But I'm gonna run into that stuff as we need it later. For right now, this should work for us. Oh my god, I'm just so happy that just worked.
That is awesome.
That is so awesome. I wonder if it will continue to work. All right, so...
that is the real question, isn't it?
So I don't think we need to normalize this. I'm just going to save us the normalization here. So the reason I'm doing that is just because we're going to end up normalizing later, and so I don't want to do more than that. I'm just going to make sure that this still does what we did before. He stabbed. I'm going to look to the left. Oh, that's looking beautiful. He looked at the camera when it turned around. Camera's trying to fight me now, but that's okay. All right, cool.
Pompadourian.
So, Pompadourian. All right, awesome. So, what we can do now is... I could put these into one call, but I'm not going to. We'll just leave it like this for right now. So, we have his position. We're going to change his transformed up position now. So, I want to actually do the normalization here. So, dot normalized. Because it's more useful to us then. This is an actual forward vector that we want the player to be along. So we can adjust his position by the movement direction versus player forward direction. Oh wait, no, that's fine. We can just use the player forward direction now. So player forward direction times speed times time dot delta time. And then we finally do all this other stuff. I'm going to put this where it actually belongs. This is part of the gravity vector calculation.
Mm-hmm.
Apply gravity. And let's see what this does.
This is very interesting.
Yeah. I'm excited this went together so well on the show.
Yeah.
I'm just getting lucky as usual. So we'll just hit play. And we're going to rotate and move around. Oh, yeah. Okay, so
we got the
I forgot to do a multiply here, I think. No, wait. Player forward direction times speed times time to delta time.
That should be it, right?
Yeah. Feels like he's kind of going slow.
He's definitely going slow.
Yeah.
Now, why is he going slow? He's also bouncing.
Yes, he is.
There's a vibration happening right now. Whoa there.
It's great when he's not on the planet.
Yeah, we might be fighting internally with some other math
This
functions.
is looking pretty good, though, otherwise.
Yeah.
Like, I'm pretty happy with how this has turned out.
So we just need to
and
figure
you can
out
see
why
the
he's
camera's
moving
kind of loose now.
Yeah.
We can really fight it by going backwards, which is something we'll fix, but we're going to have to do a lot of love for the camera, I'm sure, by the end of this project. Camera work can be tricky. Camera work can be really tricky.
The craziest things, like if you think about Mario Galaxy specifically, like their camera work
is impeccable. It's just like first of all, their auto cameras are great. Second of all, I know that their designers actually go through and hotbox the heck out of their whole game to make the camera not break ever. And when I say ever, there's still places where it occasionally breaks, and then there's places where they have fun with it too. Like there's some places where you can like run around planets where it doesn't even follow you. Like it'll just let you run on the backside of the planet, and you won't really even see your character for a little bit.
Yeah, it's pretty.
You'll
amazing.
just hear him moving around. All right, so let's try and figure out why he's getting that problem. So I think the problem is we should probably be doing his position after... Wait.
Are we setting his position 2 times somehow?
Let's take a look. So position.
At the very end of that call, we're setting his position.
Yeah, we're doing it based on the
velocity,
which is the gravity stuff.
And that's just
that's the
shake
camera. Actually, we disabled the shake, although we can put that back in.
Stay on sphere. What does that do?
So stay on sphere. This is the thing that actually pushes our character out. Remember, our spheres are actually triggers.
Yes.
And this is actually probably what we're fighting, if anything. Because we're probably pushing the character slightly into the sphere in some way, and then it's pushing him out. So, how best to solve this?
The answer isn't going to be magic.
No, probably not magic. But, so stand sphere gets called on trigger enter and on trigger stay. I think we tried this once before with very bad results, but I'm just going to try it again. So now it only does it on enter. But I think we'll probably have falling through the world problems. Yep, there we go. He goes tap and then he falls through. Yeah,
That's funny.
it is funny. All right, so we definitely need this or some equivalent. So let's see what stay on sphere does. So stay on sphere moves the position to just outside the sphere. I'm gonna just try something here. I'm gonna put a 1 there.
Okay.
Just to make it so that he's slightly
Maybe
above it.
less fighty.
Whoops.
That's funny.
Okay, so it is less fighty. You can see that the movement now is kind of how we had it before. Now it doesn't look right because he's constantly falling towards the planet.
Yeah.
But this is a good maneuver.
Honest,
This is a good move. So this is a good start.
And if we change that back to 5, he'll be fighting again.
Yeah, he should be. Let's hit save and just confirm that. Yep.
Yeah, he's definitely fighting. Interesting.
All right. Do we have anyone on channel by any chance or?
Yeah, we have a few people in here.
Evening.
Good evening. How are you, gentlemen?
Never fails. Somewhere there's a reference to
All your base.
zero wing,
Yeah.
or all your base or whatever. I love zero wing.
All your base are belong to us.
All right, so camera transform position plus equals velocity times time dot delta time. So I would have expected that we would have moved him first, then not had a problem afterwards because we're doing the velocity calculation afterwards, which was, well, no. Okay, so from the perspective of on trigger enter and on trigger stay, which is what we use for stay on sphere, from its perspective, we've already done both of these moves. We've done the transformed opposition move, and we've done both transformed opposition moves. So it's one unit at this point. So it's not like the position of this within this function will fix us in any way. So
Create 2 sphere colliders, one a trigger just above the second used for the collision. Like a planet and an atmosphere.
yeah, we could do that where we just take our planetoid and we change it so that so we have a gravity well already. That's another thing, and we could have the let's duplicate the gravity well, and we'll call this the planet surface. I don't think this is going to fix it.
I don't know if it will fix it either.
We can make it slightly smaller, which would make it so we push out. It's going to make us bouncy. It's going to have the same problem as the other thing. I'm actually not going to bother with it right now. I do like the idea though. It's good thinking, and I would
definitely thinking outside the box.
Yes,
kind of
yeah, and actually it's great because the thing is, like, in game development, people don't realize it. People are always like, "What's the right way to do it?" It's like there's 1,000 right ways to do it. The right way is whatever happens to work. In my opinion, the right way to do something is the way that gets it working. And then once you get to that point, you can start working on the engineering / code aesthetics point afterwards.
Yeah,
Get to the point where it works first, and then on your next project you'll have more organization because you know it worked from the previous one.
I mean, the only thing that I would say is if you find out for some reason that it's eating up a lot more processing time than you're expecting, then maybe
obviously if you can if you can clean it up, clean it up.
If you can't, if it works, then who cares?
Yeah, exactly. And the thing is, it's not hard to reorganize things later as long as you have some small level of organization, even just in your head, of how things work. when you're working on a group, it can be more tiring and more difficult just because you've got other people depending on you. But you are also depending on them for different things. So just keep that in
Additionally, you
mind
also
and
have
give
to-
each other slack on projects.
To deal with someone else's code style and
Yeah.
naming conventions, all sorts of things.
Yeah. Yeah.
Aesthetically, what their code looks like.
Exactly. Code aesthetics is a very real thing, and I produce an aesthetic on this show, which I'm not sure if everyone agrees with or anything, but like it, I try to maintain consistency with Unity's naming conventions. I don't use C#'s naming conventions. Like C#, every if you have a property, it's supposed to be not camel case. It's supposed to be capitals. It's going to be alternate cap case, like not alternate cap, but like jump offset would be jump offset.
Really?
And it does that for pretty much anything that's either a public variable or a property. But Unity doesn't do it that way, and I actually prefer it the other way, and so I do Unity's way. But, I mean, you're going to have people who
There are different
disagree.
aesthetics, and there's no real right way.
Yeah. That being said, if you are working with a group, I do recommend that you just decide on a code style. Just because it will make your life easier. And if you're coming into a project anywhere, like if you get hired onto a project, the rule is code chameleon. Code like you see the other code look. And it's very simple to follow. And if the other code is just really just convoluted and you're not near the end of the project so that people look at you funny, talk with people. Say we should maybe reorganize this a little bit before it gets out of hand.
But don't take offense if they don't want to do that.
Yeah, don't take offense if they don't want to do it, and don't suggest it if it's the 11th hour on the project. If you're shipping in less than a month, don't say that. You're not going to get any smiles.
No, everyone's going to be very angry.
So, not necessarily angry, but they're not going to be happy. So,
yeah, angry may have been a strong word.
yeah, I've seen it be angry, but it shouldn't be. There
Anyway,
shouldn't be any anger.
Let's continue with our
Yay! All right, so
maths.
So transfer dot position plus velocity plus equals velocity times time dot delta time. So
Stay on sphere is really where the problem is lying.
Yeah,
right now.
yeah.
Is it worth it to do that earlier on than the very last call?
Well, the stay on
Is it
sphere
not
isn't
the-
a
it's not
last
even
call.
the last
It's
call at
a
all.
trigger
It's a trigger.
call, which
Interesting.
means that it is a last call in a way, but it's outside of the calls.
Yeah.
It's outside of the update loop. So, let's see. On trigger stay. Right now we're doing this in update. Okay, I'm going to try something just because it may matter in this case. It's not going to look good. I just want to see it. It's going to call her Jerry again, but I want to see if it fixes the problem out of curiosity. It did not. It actually made things terrible.
What did?
I can't. I made a fixed update, so that's just terrible. It's
Oh, yeah.
worse.
No.
I was just hoping that maybe that would do something, but it did something. So I
It
guess
did. It made it
I was
worse.
successfully hoped.
Maybe a late update? No.
Yeah, late update. I don't think happens after the collision response, but let's try it. Let's just for fun
For funsies.
late update this.
It's just a thought. I don't think it's the right thought.
Oh wait, we already have a late update, so let's just
It's kind of how I tend to do things, though, is I try
let's call
things
this
out a lot.
late update for right now. Because we don't care about the camera shake too much. Nope,
about the
still a
same.
problem. All right. So what I'm going to propose for our next try is I'm going to, instead of changing the player position within the triggers, we're going to actually do this in the update loop so we have more control over when it happens. And we're just going to set a Boolean in the triggers to say
Oh,
to
I
do
like
it.
that. Yeah,
So
I like that a
so
lot.
let's create a private bool. This is kind of like what we did for shake camera. So shake camera, when we do here, we set the bool for where is it? On collision stay. No, wait, where was it? There it is, shake camera. So we would just set shake camera equals 2, and we would invoke stop shake so that it would do the things that we needed to do in other places. So that's what we're doing here. We're gonna do private bool.
And yes, when in Rome, do as the Romans do.
Yes.
That's a comment.
Grounded, not grounded. We want what are we gonna call it? We're gonna call it inside I'm going to call it inside planetoid. Because that's actually what this is representing. So if we're inside a planetoid, then we have to rectify it by using stay on sphere.
Yes.
So we're going to now do on trigger enter, instead of doing stay on sphere, we're going to do
we're gonna say
inside
planetoid equals true,
yes, right? Yes. Inside planetoid equals true. And then we're going to do the same thing on trigger stay. Instead of stay on sphere, we're doing inside planetoid equals true.
Are we going to be setting that to false at the end of the update loop every
Yeah,
frame
at
then?
some point in the update loop, we'll set it to false.
Yeah,
It'll be after we do the
want to do
calculation.
it after we...
Yeah, we obviously want to check it first and then set it to false.
Exactly, exactly.
So however we want to organize that. So putting it at the end guarantees that, but we could also maybe put it in the middle if it makes more sense.
It just whenever we do our movement calculations.
Yeah. As a matter of fact, probably the best place to put it might be, we could probably still use stay on sphere because this does what we want as a function, and we could probably put right in here inside planetoid equals false.
Oh yeah, that's a good idea.
And that way it stays kind of organized. And
because then we can at least keep it in that function.
And it really doesn't matter where we put it in here, but
No.
I'm going to just put it in there.
That's just...
And because the check is going to be outside of this.
That's a readability thing that it
Yeah.
makes sense. Like, okay, now I'm finished with this, now let's set it to false, instead of setting it to false and then doing the logic.
We're going to run... stay on sphere takes a collider. Okay, so that means that we're going to have to do something else as well. So we need to store the collider... I guess we could assume that the planetoid is the one that is our gravity source. So I'm going to change it to do that. So instead of requiring a collider, we're actually going to get the collider from... So we called it call, right? Yeah. We're going to do collider call equals gravity source dot collider. That should give us the one that's on the planetoid itself, the way we've organized this, and not the one that's on its child. Yeah, that'll work.
Neato.
So, and then the rest of it I don't have to change because I still called it call. And now we can just call stay on sphere from here, and we can try it a few different places. Let's just try it first up here.
Just the very first thing?
Very first thing, and see how it works.
See what happens.
So we're going to hit...
Oh.
Expecting a semicolon, yep. Probably should put a semicolon.
Yep, stay on sphere does need a semicolon.
Save. And I'm going to kill this so that it doesn't keep happening.
Oh, never mind.
Alright. So if I hit play now...
Okay, so we obviously... Something has gone wrong.
Something has gone interestingly wrong. Alright. Oh, it's probably because...
Let's try putting it down farther.
Alright.
Because obviously something went wrong.
Alright, let's try it at the end. Which is honestly kind of where it was before, I think.
do we want stay on sphere equals if... Do we want to put that call in an if statement to where if stay on sphere equals true?
Well, it doesn't return anything, so...
No.
It just does the fixing. So let's see what happens. If we hit play...
Same thing.
Where's our player? I'm gonna move him. I'm gonna try to move him.
Can't move him.
Alright, so we've done something wrong. Gravity source dot collider. Maybe the gravity source dot collider idea wasn't so great.
We could always revert it back a little bit.
Yeah. Call to transfer that local scale. Do we even care about the collider itself?
Do we care about the collider?
So what do we use call for? Call. Not this one. Not that one. That one. Okay, so we're just getting its transform, and we already have it as a transform as the gravity source. So I'm just gonna actually not do this, even though it shouldn't make that much of a difference, and just use gravity source dot transform, which I think I did it that way. Let's double check. Gravity source, yes. So let's also do a check here just in case. We arguably should have a gravity source at this point. I wasn't getting a null reference exception, so I'm not going to worry about it. I'm going to hit play again. Yep, we're still falling to the center of the planet for some reason now. Alright, so gravity equals true, velocity equals vector 3.0, transform.position equals gravity source.position minus gravity vector dot normalized times gravity source dot transform dot local scale dot y times 0.50. So local scale dot y represents the diameter. We're pushing it away from the center, so we need the 50% is the radius. All right, let's do some debug logging.
Okay.
So debug.log gravity vector.normalized. Label it gravity vector.
So we know what it is.
Plus gravity vector.normalized. Let's just start with that. Let's see what we get. So -1. All right. Point. So what does this actually look like? So that's pointing downwards and slightly in a different direction, probably because we're not right on the top of the sphere.
Yeah, we are not right on the top of the sphere.
And so we're using negative gravity vector dot normalized. Let's go ahead and do this. Let's debug all of these. Debug.log.
Debug logs are a good friend.
Gravity. Yeah, especially considering how broken the debugger is now on this. Maybe that will be fixed soon, I hope. Not gravity. This is what are we doing? The gravity source.
Yeah, we were looking
okay,
at
so gravity source size is what I'm going to call it.
Make sure to put a plus there.
Radius. Actually, no, not radius. We'll call it diameter.
Put a plus there.
Thank you. File save. Hit play. Alright, so gravity source diameter is 1. So that's obviously wrong.
Yes. Is it because it's normalized?
Well, we're not normalizing the gravity source vector. Local scale. So I'm going to hit play again and I'm going to pause this real quick. I just want to make sure that if we go to the player and check out his player movement stuff. So gravity source is gravity well. Oh!
That makes sense.
That would be the problem. So for some reason, he's owned by the gravity well and not owned by the planetoid. And why did we not have this problem before?
I do not know.
Oh, because we were using the collider.
Yes.
Got it.
Okay.
We didn't notice it before. Perfect. All right. So what we need to do is when we... So gravity source equals col.transform. We don't want that. We want gravity source to be equal to col.transform parent dot transform. Wait, no, that already is a transform. Dot parent. That's all we need.
Yeah.
Okay. So now if we hit save and hit play. Okay.
Well, we're on
looking
the planet
better. We're on
again.
the planet.
We're on the
can't
planet
move it all
again.
now. But that's looking better. So now let's try playing around with stay on sphere. So what we're going to do
Put it back at the top there.
Yeah, we'll put it right at the top.
Yeah, we changed
Save.
a few things at once. So
Hit play.
okay, interesting.
What?
That's interesting.
No, that's horrible. Wait, why?
No, interesting did not mean good.
I know, but it's still horrible. Planetoid transform. So we're on there. Yeah, it's a planetoid.
Let's look at our console. I don't think we got rid of our logs, right?
Yeah.
30 and 0.
So So the gravity vector is 0. Why is the gravity vector 0? Oh, because we're in the center now.
Mm-hmm.
But why did we end up in the center? So let's hit play and then hit pause real quick after it starts.
We're still at the center, right at the very beginning. Weird.
It's probably because the first time through we don't even have a gravity vector set.
That would be it.
So let's do this after the gravity vector here. Save. And then we're done after that because it's already in the center of the planet and doesn't care anymore. Oh!
Oh, look at that! Look at that!
Oh, the jumping sucks now.
Jumping does suck right now. He just kind of hovers.
He can hover.
That's awesome.
All right.
Well, okay, so we're getting closer.
We're getting closer. We're getting closer. So I think I'm going to call this a good time to maybe do a check-in of the player movement script. I'm going to do that real quick so that we have something relatively unhorrible to work with. So I'm just going to drag this into Perforce. We're going to submit this, and I'm going to say
Hovercraft.
Hover
Pompadourian.
Pompadourian.
And that way we at least know where we're at.
Kind of. It's not
It's
the
still
best
Well,
description, but
it's okay.
funny at
Perforce
least.
check-ins as the project goes on turns into mush.
Oh, God. Unfortunately, so... Well, and it depends on the department, too. I've noticed that, like, the art and design departments turn to mush real quick.
Like, it's just like... Bleh.
Programming department tries to keep it together, but eventually at 4 a.m. it becomes AJKFDSYT. And
Just
then,
work, just work,
yeah,
just
or
work.
just work, or who wrote this? Oh, I did. So, So we got Stay on Sphere working. So let's see if we can do this. Maybe we should do it a little bit later. Let's try doing it after we do the jump thing.
I think that's
here.
a good idea.
I'll save. Oh, I know the problem. I actually do know the problem. So one of the things that we're doing in Stay on Sphere is we're setting our velocity to 0.
Okay.
So why would this still... Maybe this is not the problem. I'm sure it's related to it, though. I'm pretty sure it's related to it. I'm just going to start moving it around before we speculate on that. So let's try doing it after we apply gravity.
Sure. Yeah.
No, because that's going to zero it out, right? We don't want to do that at all.
After we apply gravity?
I want to do it. Let's do it after we do... Let's do it between here. Let's try it here. I don't think it's going to work, but let's give it a shot. I think it's going to still be a hovercraft. Nope, can't move. Jumping sucks, too.
So that's incorrect.
So that's really bad.
Maybe just
Oh,
before the...
I know the problem.
What's the problem?
We're missing a check. We're going to put it right back where it was before, which I'm going to undo to find out because I don't remember exactly where it was. There it is.
Right there.
It's right here. So the problem is we don't want to stay on Sphere every time.
Oh, yeah. We
only want to do it if we are inside a planetoid.
That's right, because there was a reason we made that bool.
There is absolutely a reason we made that bool. So we hit save, we hit play, we can move around, we can jump. It's great.
Yeah, that's pretty fantastic.
And the camera kind of is cool now, and we can tell that the camera's kind of cool now, unlike before.
Cool.
We were working on the camera, we couldn't even tell if it was cool or not.
That's pretty cool.
This is... I'm impressed. This is actually some of the most complex movement code I've done, and we did it on the show, and it ended up working nicely.
Yeah, that's pretty awesome, actually. And we have a Pompadourian.
So maybe people will have learned some cross-product stuff. We now have more tools at our disposal. We see how you could have to end up massaging things a little bit. That's awesome.
Yeah, that's really cool.
So, what should we do next?
I don't know.
So
I'm just so happy that this even works. I
know. I just want to play it now. Let's just play this game forever. with our little
What's the-
Pompadorian.
what's
I
the
can't believe
goal?
he just works. Like, here, you get over here. You touch this guy.
I'm gonna touch it.
Yeah, you should just get a feel for
Oh,
it. It
wow.
actually feels pretty smooth.
Yeah, it does.
It feels way different than the rotating thing, like the relative rotation thing.
Why can't I get on this planet?
Because it looks different than it actually is. Like, the planet's small, so... I don't know, maybe...
Like,
There we go,
There
we
we
got
go.
it.
Oh, okay, good.
Woo.
Sweet.
No, it's because it all broke.
That's pretty cool. It feels kind of good. I like it. I do like it.
Ah, almost. There we go.
Papadorian, what are you doing? Look at him go. He's a little jumping bean is what he is. So if I just... boop, boop. That's awesome.
That's pretty cool.
All right, so I'm gonna get rid of those debug logs because we don't need them anymore for right now. And we've got 10 minutes. What can we do in 10 minutes that would be cool?
I don't know.
So let's make an enemy. Just make a little Goomba type dude or something.
Okay.
It's gonna be a sphere for right now, but so I'm gonna create a sphere. Actually, I'm gonna rename these capsules to. I'm gonna leave these in the project just because I want them in there for when people open the project later, so that they can see our little worksheet here. But yeah, so this is right word vector. I'm just gonna create. Actually, I'm gonna create a new empty game object here real quick called vector cross product worksheet. And I don't care about the relative positions. I'm just gonna throw them in here. Alright, so rightward vector, camera, forward vector, player forward vector, and gravity vector. And then we're just going to hide the whole thing. I just want to leave it there, though, for posterity. So what would we start with for
A cube.
cube? Yeah, cube may be actually better than a sphere because we'll actually know how he's facing.
Mm-hmm.
So yeah, let's do a cube. Why not? It's going to be a lot like Hyper Solar System Plumber. Remember the little
Yes,
pixel
oh.
Goombas?
Oh, I do remember
Yeah.
that game.
I actually really liked that project. That was fun. Wait, what is this? That's a sphere that I made that we're not doing anything with. So what I'm going to be doing is basically cannibalizing a lot of stuff from the player movement. What we should probably consider doing is generalizing this in such a way that the player can use it as a separate component and the enemies can use it as a separate component. Although I'm not sure if I'm going to be able to do that on today's episode.
Mm-hmm.
So let's just start by doing some copy pasta.
Sounds like a good plan.
So I'm going to actually just duplicate the player movement script, and we'll work down from that.
Call it enemy movement?
Yeah. Enemy movement. And we have to change it here so that Unity doesn't complain. So, there, we're done. We have our AI, so what's going to happen now is the cube's just going to totally not do anything, because he doesn't have a rigid body, I guess. Or wait,
Yeah, he needs
what
a
does he
rigid
need?
body, probably.
Oh, he needs the script, actually.
That would help.
That would help.
Even more.
So, enemy movement. And he's going to need a... So, what does this guy have for a collider? He has a rigid body kinematic, and he has... Does he have a collider somewhere? Oh, he has it underneath
Skybox and
for some
Sun
reason.
Source is something that we have a recommendation of.
Okay. Well, let's make a All right. Actually, yeah, let's do that. We'll do the enemy later. Because we have a request. We'll do it next week. And skyboxes are pretty easy. Just need to delete this for now, too.
What?
Yeah, why not? We just lost all that work of hitting duplicate. So, and changing the name.
Was a lot.
So I'm going to save project, save scene real quick. And let's look at... actually, let's do a check-in real quick, too. Let's go ahead and do a full reconcile on this. And test scene and player movement, that looks right. And check it in. Pompadourian camera relative movement now works. Yay. Yeah.
That's pretty awesome.
Alright. So, Skybox. So we already have some standard assets Skyboxes in here. And so what I'm going to do is I'm just going to apply one of them, and I'm going to discuss what's in a skybox and how you make them yourself. So we've already got the Sunny 2 skybox. I think that's going to be an appropriate one, even though we probably should be doing space. But let's just start with this. So we're going to do a... what is it called? In the...
I don't remember.
Graphics? No, render settings. Here it is. Render settings. It says skybox material. So we're going to put Sunny 2 skybox in here. And we're going to hit play. And it may still not work. Oh, it did work. So there we go. We've got a skybox. So now, what actually goes into a skybox? So you can see that the skybox is more designed for first-person shooters that don't have the ability to go in any direction, because the bottom is really lame.
Yeah.
It's just gray. And what skyboxes are is, in Unity, there's a few different ways you can build them. The most prominent being actually building each separate box that is in the background. And so what these end up being is, so this is like your front-facing, back-facing, left-facing, right-facing. And let's go ahead and find these textures real quick. I'm just going to find the... How do I find that texture? Is there a way to... There it is. So I'm going to just grab these and actually open these up in a image editor of some kind. I'm just going to copy them over for right now. When you move things out of Unity, it automatically goes into copy mode, so you don't have to worry about it being removed from your project. So I'm going to open up Pixelmator. You go ahead and use whatever your editor of choice is. This is my editor of choice because it's relatively cheap and it does most of everything that I need. I will say Photoshop is really nice to have, but it's also expensive, although the subscription thing makes it possible these days for small companies. Still sucks to pay like $40 a month for a piece of software, but it's certainly a better option than sometimes having to dump $400 to $800 on a piece of software. So I'm going to just do a new document. We're going to make it really wide. How big are these actually? Oh, they're huge. Oh, 1024 by 1024. Wow.
That's not as huge as I thought.
That's still pretty big.
1024 by 1024.
Yeah. Let's not do that. Let's just do 500 by 500, and we'll just resize these things. So, put these in here. And what we're going to do is each of these layers... Oh, they're semi-trans... Weird. That's the reason they're coming out so weird on the desktop. I wonder why they have transparency.
Have alpha channel. Interesting.
That's weird.
It's kind of weird.
So... Actually, let's resize them outside of here. I'm just going to use preview real quick.
That is strange that they're somewhat transparent.
Resize... Tools. Oh, whatever. Let's do it the old-fashioned way. So I'm going to open up the left, front, and right, and you're going to see that they're all the other way. Same.
No, they aren't.
Oh yeah, it's this way.
Yep.
So despite being called right and left.
Yep. See, those match up.
So the front, left, right, and back ones basically create this continuous mural. And the top ones have to connect on all four sides of the top. Mm-hmm. and the bottom one has to connect on all four sides of the bottom. And they made the bottom one easy by just making the bottom half of these just a flat color, and then the bottom one is just basically, if we look at the bottom one here, sunny down, you'll see that it is just pretty much a constant color. Actually, I think there's a slight, there's a very slight circular gradient. You probably can't see it at all on the other thing, and they've got a little dot in the bottom for no apparent reason, as far as I can tell.
They have a dot on the bottom?
Yeah, there's a little dot on the bottom. Here, let's see what it looks like in the scene. Actually, I'm sure we can see it.
Oh, there it is.
It's probably pretty big in the scene too. So all these get stitched together so that it looks relatively seamless. Yeah, you can see that brighter dot at the bottom. It's really big now because it's stretched out across the screen, but it's there.
Interesting.
So you can make your own by doing that stuff. If you're not too worried about wrapping, or like here, even though I'm moving past time now, let's just go ahead and make a really quick and dirty version for stars. This is going to be a really ugly star map, but it can show you how you can do this stuff without necessarily having to worry too much about the seams. You may notice, like if you have seams, you'll notice the cube. Otherwise, it'll look like a sphere around you. But if you have seams, you'll start to see where the edges actually are. So I'm going to open up Pixelmator, and I'm going to create a new document. And so I don't really have. So if you're using Pixelmator, this will work. I'm sure that GIMP has this type of stuff in it as well. Actually, we'll do 1024. Why not? We'll just do the same res that they're doing. And what I'm going to create here is a really basic star field, and the way I'm going to do it is by using noise. We're going to go into... Do I have noise? Is there noise? Is there a search thing?
I don't see noise.
No noise here. Let's just do all effects. Oh, and they're still sorted, so that doesn't really help us. I was just hoping that there was going to be an alphabetical noise. Stylized noise. All right. So let's look at noise. All right, so noise. This just generates noise. And actually, let's cancel this. First, I want to fill this thing with black. Actually, let's do a dark blue so that there's a little bit of a style to it. But we want to do... What is it called? Fill with black. Oh. Haha. All right. Then we'll do noise. And if you do monochrome, it's just black and white, and the density is the density of the amount of pixels that gets shown. And if you do non-monochrome, it's actually random color, which is kind of cool, but also kind of looks strange. I'm going to just go with monochrome for right now, and we're just going to make a slight background radiation style noise to it.
Yeah, like that, about 10 maybe.
Yeah, let's do 10%. And then what I'm going to do is, so that it reads a little bit better... Actually, let's just see how this looks. Let's just try this first. So I'm just going to call this Noise Stars, and we're going to call it we're going to save it as a PNG.
Not a TIFF?
Not a TIFF. Even though the ones that we just looked at were TIFFs, I don't know what they were thinking. Especially considering there's transparent TIFFs. Who uses that format? TIFF is like the poor man's PNG. So we're going to put this into...
Do we have a textures? It's probably in...
It's in materials, yeah. So let's open up materials and go into textures. And so now we've got this noise stars thing. Now, one of the long way to do this would be to individually set up each... Basically, yeah. So you would set up each one of the 6 sides separately. But there's actually a faster way we can do it. We can actually change this to a... what do we want? It's actually reflection, I think.
Is it?
Because this should turn it into a cube map. And so we will just do... So if we do 6 frames layout, it'll just take all this and put it on all 6 sides, which actually is exactly what we want. But there's some other ones that can kind of work, although they'll generally create... what would you call it? you'll get like cowlicks. You'll get the problem
Oh,
with like
interesting.
spheres
Swirling.
where you get like problems at the top and bottom.
Like which we actually
So-
have on our planet.
Yeah, you can see it right here. You'll get this kind of thing at the top because you're doing spherical mapping of a thing. The 6 frames layout will probably look the best, so I'm going to go with that.
Do we
hit
want
apply.
bilinear filtering?
We'll leave it at bilinear.
Bilinear, yeah.
So now you have noise stars, and now you'll see that it looks like it has a little sub thing here that's actually the texture, but it now actually represents itself as a reflection map, as a cube map. And so like sky here is a cube map. We made this back when we were doing the reflective stuff.
Yeah.
Because cube maps are used both for skyboxes and reflective stuff. Now, I think you can make... Let's make sure that I'm not crazy here. I'm pretty sure you can make a skybox shader. That's not what I wanted. Skybox material, not shader. I get the terminology confused and then I click on the wrong things. So it's skybox material. Skybox test. And if we go to... render effects, skybox. So the skybox cubed. There we go. So skybox is the normal one, but either one of these will count as a skybox. So if you go to render effects, skybox, it gives you the individual textures, and you could just drag it in all 6 times. But the faster way is to just go to render effects, skybox cubed, set up your cube map using the import as reflection, which is not what you would think, but that's just generates a cube map. Then you drag it in there as a cube map. And so now if we go into our render settings and use the skybox test, we should have a very ugly looking star field in the background. But there it is.
Yeah, it's there.
And it would be incredibly difficult to see because of the fact that this is pixel noise, there's really no concept of edges. It'll just blend in because of the noise aspect. So this should look pretty good. But it doesn't really look like space. We can do additional things to actually make things look a little bit better. One of the things that we can do is we can make it so right now all of the pixels are pretty dark, but we were just adjusting the density. All the pixels are actually, I think, if we zoom in on this, before I say what I was about to say, let's make sure. Okay, so they are various values.
Yeah, they aren't consistent
So
necessarily.
let's go to color management. No, that's not what we were going to. Color adjustments. So it will be different depending on your program here, but almost every photo manipulation program has the ability to change the channels, brightness, etc. And so let's see what levels I think is the one that we want. So I'm going to double click levels. There we go. So we have a histogram and we can really adjust things. So we can make some of the dark ones go away, and we can make some of the bright ones much brighter.
Oh, I like that.
And we can just basically choose a band in there to get kind of a cool
like
Starry
that.
Night effect. I'm going to hit OK. And so
Zoom out.
now we're going to zoom back out. So there's our
Wow.
100% right
That's
there.
cool.
And I'm going to go ahead and just export again, save
As a
as a PNG.
not as a JPEG or a TIFF.
And what did we call it before? I guess it's just on the desktop, right? It's just called Star. Wait.
Where is it?
Noise stars.
Oh,
There we go.
Noise Stars.
Save. Replace. And then we'll just drag it in and replace the one in here.
I'm okay with this.
And theoretically, if we... Oh, wait, you didn't replace it. Okay, so... Oh, I know what I want to do. Let's delete this. So the best way to replace something is to not let Unity know about it. So we'll just go to... it's true. We'll go to Reveal in Finder, and we'll just drag Noise Stars in and replace it here. And then Unity should just pick it up. There we go.
Yep.
And
Oh,
now
that's
we
much
have
better.
more of a background. Now we got some mapping problems. There's a few different things to fix, but at least we've got a start on this. And actually, I'm gonna call this a wrap at this point. So actually, I want to fix the map mapping. Let's see if we can
Let's
do that.
fix up edge seams, too.
So fix up edge seams. That's probably more. I don't know what that does. Certainly took some calculation.
Yeah, it did.
I don't think we're going to have a problem with edge seams on this. I think it probably tries to blend. What I would guess that it does is it takes the edges, passes them over each other slightly, makes them semi-transparent, and then blends them
Tries
in some
to
way.
blend 'em.
So, and brings them back out. So I'm going to change this to advanced. And since we already had it set as a cube map, it'll say full cube. And actually here, now it says maps, so now you know what you're getting, as opposed to reflection, which doesn't always make that much sense. Let's not generate maps and see if that looks any better. This may cause more of an aliasing effect, but yeah, so we
definitely
got, like,
causes
serious...
more of an aliasing effect.
So, but we don't have that weird triangle thing, but we have aliasing. We could adjust our aniso level and make it much less... no, it's still pretty crawly.
It's still... It takes a hit on performance, though, when you do that. That's for sure.
Yeah. So let's not... It's not a huge hit.
No.
Anisotropic filtering has gotten to the point where it's almost like bilinear filtering as far as what people expect. So, so how do we make this not look like that? Probably the best way to make would be to make it less noisy. Yes. We may have to fix this in art, quite frankly. So I'm going to go back to generate maps, though, and see if there's any setting here that will make it look not terrible. So that looks worse. So that's linear space. Let's try border maps. Let's see what that does. Okay, you can still see the polygon there, although it's not as pronounced. It's not really a polygon; it just looks like a polygon. Let's try fade out maps. All right, and this will adjust our ranges somehow. And maybe get rid of this range. I may be done with this in a second. Yeah, okay, I'm done with it. I'm over it. I'm just going to put this back to reflect. Hit apply. And we'll deal with that more on the next episode. So I'm going to save scene, save project, quit Unity, just to be double sure. And we're going to check in whatever changes we may have had. So reconcile offline work. Oh yeah, we got skyboxes and testing. Yeah, cool. So we'll just reconcile that. I'm kind of surprised that it didn't change anything to project settings. Why didn't it do that? Because I thought we changed the skybox, which would have presented itself in project settings, I think. I'm just going to try one more time. I'm going to reconcile offline work here. No files that need to be reconciled. Okay, I'll trust it. So, skybox stuffs.
Cool.
All right. So, thank you for joining us tonight. I thought that was a pretty good episode. I liked that we got through some actual math stuff, some vector math.
The math part zipped by for me.
So thanks for watching. Really appreciate you guys coming in at such a late hour. I know that a lot of you guys are in different time zones. We're on the West Coast, and we just think the world revolves around us at 9 o'clock. But yeah, so thanks for joining us tonight. If you have any questions, please contact me at pushypixels@pushypixels.com. You can also tweet me at Drakfire, DRAKFYRE. And you should buy Phil's game, Robot Alone. It's on iOS and it's fun.
It's $1.
Yes, it's $1.
Yeah, you can email me if you want to, philip@protosoftworks.com, or you can follow me on Twitter. That's right, I have a Twitter.
He has a Twitter.
Crazy. It's crazy talk. It's at Magma Lemur.
Why do you get so excited
MAGMALEMUR.
You get so excited about the Twitter.
I don't know.
Yeah,
I like
Twitter.
Twitter.
Every time. I know, it's great.
Because
it's
I put stupid stuff on there. That's
All right,
what
yeah,
I
you should
do.
read the stupid stuff. It's great. I don't put nearly enough stupid stuff on mine. Although I need to get those pictures from Chris. There's the public service announcement. Gary's Mod has models from Metal Gear Rising: Revengeance.
Oh, that's pretty
and
amazing.
It's pretty hilarious.
That's pretty amazing.
But I actually want to do a tweet about that,
And
but I didn't get the pictures off of the computer yet.
You know what else our fine viewers should do?
Oh, yes.
They should donate to Cooking with Unity.
Yes, please donate. This is stuff that you will get eventually. As I said, I am still behind. I'm going to continue to be behind for a little while. Bear with me. You will get your rewards. I'm keeping track of everyone. And So, but the thing is, if you donate $5, you will eventually get one of these. It's a Pushy Pixels keychain. It's light. It's a little plasticky thing, but it's cool and reflective. And if you donate $10, you get 2 of these. One of them will be signed and numbered, and the other one will, and it will also include a certificate of authenticity.
And I might
keep
breathe
one for your
on it.
keychain, and he might breathe on it. I might breathe on it. Keep one for your keychain. Keep one in your collection. And then finally, we have the coasters. These are at the $20 mark for the U.S., $25 mark for the rest of the world because of shipping. It's a little coaster. It has the Pushy Pixels logo. It's glass tile. It's pretty awesome. It's heavy, which is the reason why we have to charge extra for the shipping. And your donations seriously help us. These are not worth $20 right now. These aren't worth $5 right now. This is to help donation. We just want to give you a reward for doing it. And maybe someday we'll be famous and they'll be worth something more than $20, but they're not right now, so don't expect that. Anyway, thank you very much for joining us, and you guys have a great week. We'll see you on Thursday with more Cooking with Unity 2D Thursday.
Have a good evening.